Okay, so hi. Today we'll be talking about applying trig functions, and we'll definitely be talking about angles of elevation and angles of depression. But first, some really tricky kind of questions that you might see is a question like this. This is a great application one. So if sine of theta is equal to negative 3 over 5, what is, and you can apply this to any situation whatsoever. Let's say cosecant. No, not cosecant, because that, well, if it is cosecant, you could do it this way. So let me just put it in. Okay, so it's going to ask this. So all you have to do is just kind of recognize, oh, these are reciprocals of each other, so cosecant of theta is going to be just the reciprocal of that, so it's going to be negative 5/3. So that one's really easy. Now, if instead it had said, what is, let's go tangent of theta, okay, you're probably sitting there going, I have no easy way to convert from sine to tangent. But if you think about it, it's talking about a triangle, okay? So if it's talking about a triangle, let's make a triangle. Okay, so sine of theta is going to be negative 3/5. Okay. Oh, and you also have to know which quadrant it's in. So let's say it's in quadrant. Let's say it's in quadrant 3. Okay. So quadrant 3 is where all this action's at. Okay, so now in quadrant 3, and I should probably get rid of this triangle because it's not the best representation. Okay, quadrant 3 is over here, right here. So our line, our actual triangle, if we do draw it, is going to look like this. Okay, so that means it's going to have a negative. Okay, so negative 3/5, and remember theta's right here, so I'll 2 through 3. Okay, so theta's right there, so sine is opposite, so this is negative 3, and this is 5. And what you can do is use Pythagorean theorem to figure out that this is going to be negative 4. Now, obviously, when you do Pythagorean theorem, you're going to find out that you're going to get 4, but you have to understand, since this is in the third quadrant, both the x and the y coordinates are going to be negative. So this is going to be the signs of your points, okay? Alright, so now that we actually have that, we can actually find tangent of theta, which we can do opposite over adjacent. So tangent of theta is going to be really easy. It's going to be 3/4. Okay? Alright, and you could definitely use this information to fill out all kinds of other information. Like, for example, cosine of theta is going to be negative 4/5. Okay, and then you can use the reciprocals to get everything else. So, like, for example, secant of theta is going to be negative 5/4, and cotangent of theta is going to be 4/3. Okay, so you can use just this one piece of information, well, actually not this one piece, this piece and this piece of information to actually get the rest of the picture and actually draw this picture. So this is a great application of applying trig functions. Okay, and this is actually from the last lesson, but I wanted to cover it so that we actually had this idea down. Okay, now on this one, something as simple as what this is, you could actually find several variables just by using certain pieces of information. Now obviously, this right here is a little bit skewed. That doesn't look like 45, and you know this probably up here is going to be 45. So what you want to do is you want to start filling out some of the angles and just working with it that way. So 45. Okay, degrees up here, and this one should be 60 up here. Okay, alright, so you can actually fill out quite a bit of piece of information about this. But as you can see, the only piece of information I actually know for certain about a side length is this. This is 12. Okay? Alright, so since this is actually 12, I could actually use some actual trig functions to actually figure this bad boy out. Alright, so setting it up, it just depends on which one you want first. I think I'm going to use 30 and 12 and try to find both h and n. Okay, and I just have to remember SOHCAHTOA. Okay. Alright, so let me see. I've got the hypotenuse, and let's go with the opposite side. So h, so sine of 30 degrees is equal to h divided by 12. Okay? Alright, and so I multiply both sides by 12, so I get 12 times sine of 30 degrees equals h. Okay? Now, when I go to Desmos, or whatever calculator I have to make sure my calculator's in degrees because I am working with degrees. If you'd like to, we'll talk about radians a little later, but for right now we're just working with degrees. Okay, so 12 times the sine of 30, okay, we get 6, which makes sense because if we take a look at our chart, you know, let's get h equals 6. Because technically sine of 30 is 1/2, and 1/2 times 12 is 6. Okay, so that makes all kinds of sense. So we actually have a number right now, so let's go ahead and give it 6. So we know this is 6 now. Okay, and then we can find this. Okay, let's go back to black. Okay, so now we're going to use cosine of 30 degrees is equal to n divided by 12. Okay, and then it just turns into 12 times cosine of 30 degrees equals n. Alright, and once again, if we use our decimals, we go 12 cosine of 30. It's going to be about 10.39, and I am going to use 10.39 just because I want to keep it as, you know, close to the hundreds as possible. I don't want to cut off any more decimals than I have to. Okay, so now finding out that information, I can now focus on this triangle. Now, before I had 3 missing sides, so I couldn't start on this side, but now I have this as 6. Well, I know in a 40, and I can use some good straight up rules from special right triangles. I know that's a special right triangle, so that's going to be 6 and 6. Okay? Alright, now if you confirmed it, you could actually find out that sine of 45, and we'll use this 45 to see it as well. So sine of 45 degrees equals, let me see, opposite, so it would be 6 divided by p. Okay, now on this one I would have to switch places with the sine of 45 and the p. Okay, and so what I get is p equals 6 divided by sine of 45. Okay, and then on my calculator, so it'd be 6 divided by sine of 45, and I'd get 8.48. Okay, which if you use the special right triangles, you would get 6 root 2 as your answer up here. Okay, so those are both equivalent because they're both going to be the same. Alright, but I just wanted to show you solving by trig and just by working around this. Okay, so first off, you want to just fill in as much information as you can and then start working through it. Work with the side with at least one side and just use SOHCAHTOA to the best of your ability. Alright, now just to talk about angles of depression and elevation, let's just talk about this famous plane landing at an airport problem. Okay, so the plane knows that the altitude is at 3,900 feet. How far does the plane has to travel to get to the actual airport? Okay, now obviously we all know that the plane's probably going to come in and then land down here and then come back and taxi. Okay, but we're just talking about the straight line distance from the plane to the actual airport. Now if you notice, I only have 90 degrees here, so it's important that I designate some stuff, designate some angles other than what I have. So what that will tell you is when you're on a plane, the angle of depression is 6 degrees. Okay, now if it's 6 degrees, that means if the plane was looking straight, okay, this would be a 6-degree angle. Alright, and you're probably going, wait, that's not inside the triangle. How do I use that to help me out? Okay, well, you could use a couple of things of logic to actually work with it. You could know the fact that these two are complementary, and thus this is 84 degrees. Okay, alright, so that one's pretty simple. Or you could use the fact that these two lines are parallel, and thus this, geez Louise, that angle's, okay, there we go. This angle and this angle are both congruent because of alternate interior angles. So this would also be 6 degrees. Okay, alright, and so now working with that, you can actually figure out the distance traveled. Okay, we'll just call that D just for the heck of it. And this would be G if we wanted to find how the ground distance is. Okay, so we just set it up. We use SOHCAHTOA. I think I'm going to use, I will be using the 6 degrees and 3900, so that would be sine. So sine of 6 degrees is equal to 3900 divided by the distance traveled. Okay, and if you notice, that's a lot like this problem up here. So all I have to do is switch the variable and the trig function, and then I'm good to go. Okay, and so D equals 3900 divided by sine of 6. Okay, now if you think about what your answer is doing, okay, the closer and closer we get to sine of 0, the closer and closer it approaches 0. So sine actually approaches 0 the closer and closer that this gets there. Okay, so this is going to be a really small number. So we're dividing a big number by a really small number. We should get a bigger number than 3900. That's a good way to check your work to see if you're doing it correctly. So we go 3900 divided by sine of 6, and 37,310 feet. Okay, so that definitely helps out. So D equals 37,310 feet to get there. Okay, so the plane must start its descent a lot further away from the airport than you think it would. Okay, because if you divide that by, I mean, that's probably a couple miles. Let me see, what is that? That is, I think, almost 7, at least 7 miles out from the airport, the plane actually has to start its descent. Okay? And that's only at 3,900 feet. If it was up higher, the plane would have to start its descent much earlier. Okay? Alright, but that's it for applications of trig. Just remember, draw a picture, label what you know, and then use some geometry to help you out. Thank you very much and have a great day. Bye.